Continuing our coverage from MesosCon here in Los Angeles, I'm Scott Fulton with the New Stack. The two much taller men over to my left here are two of the co-founders of Mesosphere, Tobias Knaup and Florian Leibert. Gentlemen, thank you for being here with us.
Thank you for having us.
Yeah, thank you.
And thank you for having us. I appreciate being here in the little corner here. Now, earlier this month, there were some big announcements from Mesosphere that not everyone may be familiar with regarding the new edition of DCOS. One of the new components there, which immediately pointed my ears, for those of you who are out there, yes, I am a trekker. The Universal Container Runtime concept. That perked me up a little bit. Tell me, if you would, gentlemen, a little bit more about UCR and what the virtues are.
Sure. So Mesos has been running containers in production for a very long time. And so over the years, it's built a very sophisticated container runtime. So, and if you look at what a container is, you can kind of divide it into two areas. So a container does resource isolation, so making sure you only use the CPU that's been allocated to you, the memory, and same for other resources like network I/O and disk I/O.
Or even GPUs.
Or GPUs. And so the runtime in Mesos that does this isolation, it's very sophisticated, very stable, production grade. And then the other part of what containers do is it's a way to bundle your applications, an image, right? Mm-hmm. And so what the Universal Container Runtime is, it's that same Mesos runtime that's been there for years, and we've added image support for popular container formats, of course Docker being the most popular, but also App Container, AppC, and soon OCI, the open image format, so that you can then run a Docker image or AppC or OCI image with that same Mesos container runtime.
And one thing to add here that I think a lot of people forget. When you're running DCOS, you actually don't even need to have your application containerized. So let's say you're running a legacy app server, JBoss or something like that, and you don't have it packaged into a Docker image. You can run it, just the executable or the jar file that you have, without any modification. And I think that's always one of the things that has set us apart from many other players out there. You don't need to containerize.
Because here's the thing. I know that Mesos has not always been a container platform. It's been able to stage workloads in many different formats and in many different ways for well over a decade now. So when creating this idea of a container runtime, the way it was explained on stage, and Ben kind of contributed to this, you have the formats that you listed, Docker, AppC, and OCI coming, but you also have the ability to run workloads that are not imaged at all, that may essentially be in a zip file or just the original tarball. I'm wondering what the virtues of doing so would be.
Yeah, so this was before there was Docker. That's how people would run applications on Mesos, and a lot of them still do that today. So, and especially if you're running JVM-based applications where you have jars that contain all your dependencies and your application, that is already a packaging format, right? So packaging it again in a container packaging format doesn't really give you that much extra value, and so that's why folks can continue to use that. We've even seen some people package a Linux binary and its dependent libraries in a tarball and let Mesos unpack that and run it.
This is interesting. You're saying packaging does not, are you saying it doesn't always give you extra value, or most of the time packaging doesn't give you extra value, or there really isn't value into this whole imaging format thing that we've been dealing with for the last few years?
I think there's definitely value, but I think what Toby was describing was the use case, this legacy use case for companies that are running JVMs, and with JVMs, the JVM itself does some sort of isolation, right? It isolates memory, for example, and as you mentioned, when you have a jar, the Java archives, jar files, they are already the means to package Java-based applications. So, of course, in many ways, it still makes sense. There's still added benefit to using a image format, but you don't have to.
Right.
If your current development or DevOps workflow doesn't include containers, using our platform DCOS gives you the freedom of choice of either packaging it up or just running it as is, how you've always been running your Java applications.
This conference has been sharing space here, of course, with sister conferences with the Linux Foundation, one of which has been Open Source Summit. And yesterday at OSS, Dan Cohn was speaking about the virtues of containerization. One of the things he said, this isn't the first time he said it, but he's articulated that even more and more, is he's advising organizations, containerize your stuff and you will find virtue in doing so. Get that monolith, step one, get that monolith containerized, and automatically you'll find it's easier to scale and run. It sounds like what you're saying is, maybe, maybe not.
Yeah, I think looking at companies like Twitter who have really perfected the way that they run DevOps, they don't necessarily need to containerize it anymore. They're pretty happy, I think, as is. I mean, Toby and I actually both worked at Airbnb for quite a while, and I'm not sure it would have added as much benefit since we already had our microservices-based architecture. We already used big data products like Cassandra and Kafka, and it didn't give us as much, but I think it usually, of course, gives you a lot. If you're migrating away from a monolithic application, you have your monolithic Ruby on Rails app, and you're forced to really reevaluate all of the tools that you're using. There's certainly a lot of value in that.
Yeah, I think the key here is really choice. Like, we see a lot of organizations that have a lot of complexity in their applications, and so if you're a typical enterprise and you have that big monolithic application and it's JVM based, you're publishing it as a jar, you can run that on Mesos. We transparently wrap it in a container, but you probably also have a group that's doing new microservice based development and that wants to use Docker, so they can do that too and run it on the same platform.
And I want to add one more thing. So I think there's a lot of hype, of course, around containers right now. But if you really look at
I don't know where it comes from.
if you really look at it, I think the biggest change that had happened in the last decade was probably AWS. Mm-hmm. And why has AWS really changed the way that we develop? Well, because AWS gives you these building blocks for modern applications. And those building blocks go far, they are much more than just containers. Those building blocks are a distributed message queue that's horizontally scalable. Those building blocks is DynamoDB on AWS, or a distributed key value store. And those building blocks make it extremely easy to write a modern microservice-based application. And with Mesosphere and DCOS, what we wanted to create is this open ecosystem of a lot of open source technologies that are cutting edge technologies and bring them together on one platform. And that's also where our announcement this week around integrating with Kubernetes, that came also in really handy, because obviously Kubernetes has a ton of traction, and Kubernetes really is the de facto standard when you're deploying an orchestration framework. And so just with our philosophy around TensorFlow, around Spark, we are also supporting now Kubernetes, and I think that was actually one of the most exciting parts for us this past week, is to share this work that we've been doing for the last year or so, and making it public and accessible for anybody.
I want to fine-tune our story on integrating with Kubernetes, because over 2 years ago, when we started covering Mesosphere from the very beginning, one of the things that you have said, what Ben has said to us before and explained to me in depth, is that Kubernetes runs on DCOS just fine. So there's been a kind of a friendship, if not an integration, since the very beginning of the product. So a lot of people saw the story, DCOS integration with Kubernetes, and they say, wait a minute, that's not new. You had that before, didn't you?
We did, yeah. So in fact, we were one of the largest contributors to some of the early Kubernetes releases. And the problem at the time was that the architecture we chose for the integration wasn't sustainable. So Kubernetes was moving really fast. APIs were still evolving. And so to make it work at the time, we had to go deep into the code in Kubernetes and take out certain parts replaced them with our versions. So it was kind of a, a fairly
Frankenettis.
Frankenettis. That's right, Frankenettis. And so
that's a great restaurant someplace in New York. It's Frankenettis.
And so as a startup, it was hard for us to sustain that, right? Because we had to spend a lot of time on this integration. At the same time, we were developing an SDK at Mesosphere that we used to run all the data services, Cassandra, Kafka, and so on. Mm-hmm. And so those things are distributed systems. Kafka is Kubernetes is a distributed system. And so what we did this time around is we've used that SDK that we've polished over the last year or two and integrated Kubernetes with that SDK. So it's a much cleaner integration, and it's actually vanilla upstream Kubernetes instead of Frankenettis.
Now, the way when Kubernetes proponents, the way they advocate the platform. For instance, we've at the New Stack, we've done first in our series of ebooks on the Kubernetes ecosystem. A lot of the Kubernetes proponents will come to me and say the way you really should define Kubernetes is as a provider of virtual infrastructure. And I would say, well, I thought that's what Mesos did. So if you're putting Kubernetes a layer on top of a layer of what Kubernetes folks describe as virtual infrastructure. Ben Heinemann discussed that as peanut butter and jelly. Tim Hawkins said, no, peanut butter and chocolate. I'm wondering whether it's peanut butter and Nutella, whether it's like two things that taste great individually, but whether that maybe a little bit redundant. I mean, a lot of your customers are asking for Kubernetes support, but it's not necessary, is it?
So, I mean, I think right now, when a company decides to go down the container route, the developers are really used to the Kubernetes APIs, and I think that's really what they're looking for. And so, when you look at the integration that we have done with DCOS and Kubernetes, it's very similar to what you would be getting on top of Google's cloud platform, so where you have the Google Container Engine, right? It's essentially a managed Kubernetes offering with some bells and whistles. And what we are doing with DCOS, we have built a number of building blocks that you need in order to offer an enterprise-grade data service. Authentication, authorization, security, all these components, and now we're making those available to the Kubernetes that's running on top of DCOS. So that's how you get this 1 + 1 is 3. Do you want to?
Yeah, and we've had a lot of conversations with customers and folks that were interested in running Kubernetes, and the story that everybody told us is like, we love the API, we love the tool, we want to be part of this community, but we don't know how to put this in production. And Tim Hawkins, who was on stage with me earlier, he kind of echoed that, right? It is a distributed system, and any distributed system is hard to set up. Mm-hmm. And so that's really where the 1 + 1 = 3 comes in. It's really easy to deploy a Kubernetes cluster on DCOS with the click of a button, similar to how you would consume it on a cloud. And then there's the additional value is in the integration with the rest of the DCOS services. So it uses the same network that DCOS already provisions, and you can talk to any of the data services that we spend a lot of time on making those production grade, like Cassandra, Kafka, and so on. And you can easily build your containerized application on Kubernetes and then talk to the data services that are running on DCOS.
I heard a DCOS implementer who was here yesterday explain it to me like this. The developers are demanding Kubernetes because that's the SDK they've learned, that's the APIs they've learned. They understand kubectl, and they also understand how to pronounce it properly. So that's what they want. We need a platform that gives that to them, and then we need a platform that takes it away when it's necessary. The description is supplied to me as when you bring things into production, when you get it when you take your production greenfield containerized application, you put it with the rest of your workloads, including Spark workloads, including Kafka workloads. You need to get Kubernetes off of that and then get it running with the rest of everything. Was this fellow right, or should Kubernetes be part of the production environment as well?
I think it should absolutely be part of the production environment. I think just like any other system, right, it's easy to get something up and running on your laptop and to try it out, but then making it highly available and figuring out how to back it up and restore it, how to upgrade it, all of these production operational procedures, that's just really hard, and that's where people struggled. And that's exactly where we come in with DCOS, and we help with that.
And a lot of our customers are Fortune 50. We have about a quarter of the Fortune 50 that we count as our customer base, and we have over 100 production customers to date, and we saw an immense amount of demand in the field, and we're working on deals right now already with some early customers on this Kubernetes integration. And one of the use cases that keeps coming up is an organization like a big bank, for example, says, look, we want a couple of different Kubernetes clusters, one for test, one for prod, maybe run different versions side by side, maybe even provision different Kubernetes clusters for different lines of business. With different priorities and so forth. And that's the use case that DCOS really enables you to do. You can literally in 5 minutes or less spin up a Kubernetes cluster on your DCOS on your DCOS platform and run it side by side at Cassandra. Scale up Cassandra, scale Cassandra down, add Kafka. And DCOS is really our platform for providing these platform services from an open ecosystem and deliver them on any infrastructure or cloud.
About that talk that I mentioned Dan Cohn delivered the other day, one of the other points that he was making was with respect to migrating monolithic applications. And what he was advocating is a kind of lift and shift where you take the old monolith as a whole, get it containerized now, and then begin your process of decomposing it, perhaps all the way, but perhaps only part of the way, into microservices. Where you can have microservices kind of orbiting what remains of the monolith, but get enough microservices out there to make the application more scalable and more agile. There's another train of thought, and I've heard it introduced here in the last couple of days. The idea that instead of lifting and shifting, the idea should be to take account of all the different services that the monolithic application already provides, and then systematically create proxies for those on Mesos and DCOS, so that those proxies capture the services that would have otherwise been delivered to the monolith and says, okay, I'll handle this for you instead, and then do this over time, and then if there's any failures, all you have to do is turn it off. So there's a couple of ways to go here, to which somebody in the audience had a very interesting question, saying, since Mesos already works as a platform for handling our individual workloads, why do we need microservices again? Remind me of the use case, because we were sold on this before, but now we're not so sure. Is the trek toward microservices an absolute necessity for every organization that adopts DCOS?
I don't think it is. I think microservices and containers often get used together, but they really are separate. Microservice is an architectural pattern that makes a lot of sense for a lot of applications, but it's not a necessity when you want to adopt containers. I very much think that you get a lot of value from taking your monolithic application and running it on a containerized platform. You get health checks, you get high availability, you can leverage some of the data services that are available. You get familiar with the containerized platform. It's the first step in this journey of breaking up the monolith. And then you can just look at that monolith and prioritize, where are my hotspots, where do I need to be innovative, or where do I need to scale better, and then slowly chip away at it, break it out into microservices. I think that's a great approach.
What do you think?
Yeah, I can only echo what Toby said, and I think you can speak with a lot of authority on this, because Toby, many might not know this, but Toby was one of the first engineers at Airbnb, where he was tasked with taking a Ruby on Rails monolithic application, similar actually to the one that we were rebuilding at Twitter, and decomposing it into microservices, and then deploying those microservices using a lot of cloud native technologies.
Right. Yeah, and so there we did exactly this. We looked at what doesn't scale anymore or what's hard to do in this monolith. It was search in that case, and so that was the first one that we broke out and rewrote as a microservice, and it just continued like that.
And search is actually, it's funny that you mentioned search, but search was also at Twitter one of the first components that we had migrated out of the monorail, is what we actually called it at Twitter. And in fact, I was working on user search, which was a subset of search for finding users on Twitter. And that's when I actually reached out to Ben, whom I had known for a long time, and I knew he was working on Apache Mesos over at UC Berkeley, and we brought him into Twitter in order to say, look, this is a really good use case. This is our first microservice that we could deploy on Mesos, and that's really how the whole project at Twitter got started.
Well, at Twitter, arguably, you and Ben arguably had the virtue of being able to understand exactly what functions Twitter performed. I mean, the architecture was very well spelled out for you. So you had laid out for you exactly what you needed to do. You mean the map was there. It was probably. I don't want to say necessarily it was straightforward, but it was easy enough for you to figure out. It might have been tedious, but the process of figuring out how you build out services like search, at least you had a general idea of that. An organization that might be in financial services or that might be in transportation and logistics, when they are migrating the monolith they have, they've inherited this thing from wherever they got it from, and they don't even really quite know where, and they would like some help figuring out what the services actually are, how to make an API around these things. So if they become a DCOS customer, do they turn to Mesosphere? Do they turn to the Mesos community at large? Do they turn to the Docker community at large? Who helps them figure out what they got to do?
So there are various paths, of course, and there's customers in all waves. So we have some customers, of course, that are technology companies. So they have a lot of knowledge about architectural patterns. They know where they want to go. But we, of course, also have companies where there might be a really innovative group, but the company might have actually just a couple of years ago embraced virtualization. So there's really a full spectrum. And what we provide our customers with is professional services, and the later stage customers tend to use them more than the early stage customers. But yeah, so we certainly help on that journey. We have a lot of partners, a lot of regional and now also some global system integrators, and they also help their customers. So for example, Accenture or Ernst & Young, those are companies that help their customers with digital transformation, and they usually have a lot of knowledge about how to containerize applications, which parts of applications are easy to turn into microservices.
Yeah, exactly. So, and that's something that's obviously very specific on the business, the application, and so this really takes a lot of time, with an architect to sit down and figure out how to structure it, and yeah, our partners can help with that.
I have a question for you. What do you?
Oh, me.
So, there's a lot of hype around. I mentioned this already around containers, but there's actually one of the most successful open source projects since the Linux kernel. What do you think it is?
I have a whole bunch of people who want me to say PowerShell. Hi, Jeffrey.
Well, so actually, if you look at, it's a vanity metric, I know, but if you look at GitHub and you use GitHub stars and GitHub forks as indicators for the popularity of a project, TensorFlow actually has enormous traction, and you actually don't read about it as much as you read about, for example, Kubernetes and Docker and a lot of other container technologies.
Well, it doesn't get much on Hacker News, really.
Yes.
You can't generate controversies around it,
Yep.
Now, if somebody were to come up with, if somebody were to come up with a big time, competitive.
That's there.
TensorFlow killer.
So there's a lot of very passionate MXNet users also.
There's rising tension in the TensorFlow community.
We actually had two interns over the summer, and they were working on on TensorFlow and porting that. Like we already had support for TensorFlow, but now we ported it over to our SDK. And another intern was porting MXNet or integrating MXNet on DCOS. So it was really interesting to see those right after one another, the two presentations. But MXNet has a lot of traction. I think it's actually a bit faster in many cases.
Yeah.
So, with respect to gaining traction in the community there, I would think that Mesos has an obligation as a broader technology to engage with more with the other members of the various stacks that are emerging around it. We talked a lot here, for instance, about the SMAC stack, which includes Mesos, but also Cassandra and other components that Kafka that would help create a larger pipeline for these. And I'm wondering how, in certain situations, when you're representing a commercial element, how do you help create a community, if you will, around? A lot of the people who are attending here have heard this word, the SMAC stack, only for the first time today.
Yeah. So we actually work super closely with some of the leading companies, or the companies that are contributing the most to some of these technologies. So for example, today on stage we had Neha from Confluent, and also Neha Narkahede, I think is how you pronounce it. She's the CTO, co-founder of Confluent. And we also had Jonathan Ellis, so the creator or co-creator of Apache Cassandra, two of the major technologies in the SMAC stack. And the panel was moderated by Benjamin Hintman, who created Mesos. And what I've actually seen recently is SMAC with two Ks, so where the second K is Kubernetes. So we've actually seen that use case as well, and that really fits into our story, right, of DCOS being an evergreen technology platform where you can really easily deploy, manage, and scale modern building blocks for your own applications.
So SMAC, what would be the virtue of putting that second K there over and above what the first K already has?
So the two Ks, right, just for clarification, stand for Kubernetes and Kafka. And if you look at Mesos itself doesn't actually overlap that much with Kubernetes at all. What overlaps with Kubernetes from a functional perspective with another product that we had released a couple of years ago as an open source project. It's called Marathon. And there are a lot of use cases, especially in a large corporation, where you actually want to run both. You have a group that wants to run Kubernetes, but you also have a group that wants to port their application server, their JBoss server, over to this new stack without containerizing it. And that group will then use Marathon, because that's what Marathon allows you to do. There are also other use cases. For example, a very popular restaurant recommender site. They use Marathon at very high scale, and they actually
Frankenetti's, I think, was the name of it.
That's right. And what they're doing is they're actually doing multiple deploys per second at peak. So they're deploying applications really, really rapidly. Whenever there's, I think, a check-in or a code commit, they basically spin off an integration test, and then it gets deployed to a subset of the nodes. And they have fully automated that, and that's a very special use case. And they've actually been able to extend Marathon and make it work for exactly that case. So I think it's like building a house. You can't just show up with a screwdriver. You need a toolbox. And
he tells me this now. I got a set of screwdrivers here. I'm trying to participate. I'm trying to be helpful.
You know where we had this actually, I think, where people were trying to force a lot of technology, or a lot of solutions through the Hadoop press, right? Like I think, and out of that actually we had a new set of tools emerging that were much more specialized. So for example, for streaming analytics, we had Spark for doing in-memory interactive analytics, and I think that's how I think the world has changed. We now now have the ability to really easily bring all of these technologies together. And by the way, I don't think it's going to slow down anytime soon. I think we're going to see an even more explosive growth and more variety of open source
databases
projects.
and analytics engines. And I mean, in the past, the big barrier has always been that it is hard to deploy these new things, right? Because every new database and analytics engine has different operational characteristics. And so that's where DCS is really trying to help. So whether it's the SMAC stack or some other combination, you can run all of those really easily on DCS.
So if Kubernetes were to actually become a formal component of a stack that also has Mesos in its acronym, you're saying there would be no overlap technically. Would there be contention from a bureaucratic standpoint, from a management standpoint, or do you see the Kubernetes community and the Mesos community joining with one another in peace and harmony?
So far, our experience with the community has been amazing. The Kubernetes community is great. We've been active in the community for I think over 2 years now, and we're really happy to bring the two projects together.
Yeah, I think for us it's about solving our customers' needs, and I think the larger the organization, the more tools you'll end up using, and we want to make that simple. Deploying, managing, and scaling all of these modern building blocks for applications.
Mesosphere, longtime friends of the new stack, and that will continue for a long time.
Thank you.
Gentlemen,
thank you so much.
Thank you. We've been speaking with Tobias Knaup and Florian Leibert, two of the co-founders of Mesosphere. I'm Scott Fulton of the New Stack here from MesosCon in Los Angeles.